Okay, we are now on lesson 8.1.5, finding areas of regular polygons. So far you had a couple of formulas, finding areas of triangles, rectangles, parallelograms, trapezoids, right? So how do we use what we have plus trig, and right triangles? We're going to use all that we have so far to kind of help us figure out how do we find the area of a regular polygon, and now we have expanded it to any polygon, right? So any regular polygon, any number of sides. So let's start by looking at this. Find the area of each shape below twice, each time using a different method or strategy. Okay, so here you have a square, right? Now typically for a square we want the sides, right? But it doesn't give us that, it gives us diagonals. So let's see. Well, I know for a square that the diagonals are perpendicular. So this is 90 degrees right here. So then that tells me then, if that is true, then whatever I have on this side could be a base and this could be a height. So what I could do is figure out what this little triangle is and just multiply it by 4 because there's 4 of them, right? And so I also know that the diagonals in the square are bisecting and they are congruent. So that means if this is 6, this is 6, this is 6, this is 6. So in that small triangle, the small triangle, area of that small triangle is 1/2 base times height. That would give me 18. And then I need the area of the square, which is 4 of these. So that would be, I believe, 72. Just checking my answer, 72. So that's one way, okay? A second way is to remind myself maybe, these are not the only 2 ways. These are the 2 ways I can think of right off the bat, right? So another way would be to look at this and say, okay, well, this is a square, so what else do I know? I know that this was 90 degrees and I got cut in half because the diagonals bisect the angles. So this is 45 degrees and this is 45 degrees, right? That further proves that these 2 are the same. Those are 6s. But what I do know then, reminding myself that this is 90 degree, right? And this is a 45, 45, 90 triangle. So that means then this side right here is 6 root 2. And this is also 6 root 2. So another way of finding the area of a square is take 6 root 2 times 6 root 2, right? Now, don't forget, when you multiply something like that, you multiply number as outside. So that's 6 times 6 is 36. And then root 2 times root 2 becomes 2. So that also gives me 72. So both ways would get you the same answer. Okay? All right. For a regular hexagon, right now off the top of my head, I can think of one way. So I'm going to do the same thing, kind of the same thing that they did in part A. I'm going to go ahead and cut it up into some triangles and see if that will be helpful to me. Okay. Well, what do I know? I know a regular hexagon, if I recall correctly, that each interior angle measures 120, but because of the way that the triangle cut it, now it cuts it in half. 120 divided by 2 is 60, and so this is 60 degrees, right? Ooh, this is actually really helpful. This is an equilateral triangle. And so if you remember from equilateral triangles, we're able to, in the previous lesson, we were able to find the height right here because we cut it into 30, 60, 90 triangle. So we're able to cut this base into 4 root 3, and this is 8, right? So equilateral triangle means all sides are the same. And so that's why this is 4. Oops, sorry. This is also 4. So that proves that we have an equilateral triangle. We have 8, 8, and 8. Why is this so cool? Because now I can figure out this little triangle right here, same as before, and there's 6 of them, so I'm going to multiply it by 6. Okay, so I'm going to go area of that little triangle is 1/2 base times height, so that's 16 root 3, and then the area of this hexagon, it's very hard to draw that teeny tiny, but there's 6 of them, 6 times 16 root 3, it gives me 96 root 3, and that's my answer for that. Another way, if you are more comfortable in looking at a smaller triangle, this is another way. Again, this is not the only way, but this is my other solution. My other solution is to cut up the hexagon even more. I would cut it up into smaller pieces that go like this, where you have your height of each of the triangles. All right. So now I cut up into 12 pieces. But then I know that one triangle right here, I can see my base and I see my height for root 3, right? So then I would go ahead and say that this is my second method here. My second method would be area of this little right triangle is 1/2 base times height. So it gives me 8 root 3. And now I don't have 6 of them, I have 12 of them, right? If I count how many right triangles I have there, I have 12 of them. So I go, okay, area of the hexagon is 12 of these. So 12 times 8 root 3. Well, 12 times 8 is 96 root 3. So yes, a second method, getting the same exact answer. Okay. All right. So that's kind of helping us to lead into the next piece here. It says, give me 1 second here. It says, assume C is the center of each polygon. Notice our polygons are looking more and more like circles. Maybe there's a reason for that, right? Find the area of the 2 regular polygons below. Okay, so C is the center of the polygons, right? And let's see how many sides is this? Well, how many angles is this? So 1, 2, 3, 4, 5, 6, 7, 8, 9. The reason why I want to do that is now I want to figure out what the each interior angle is. This is why we did that topic in the previous lesson, right? So there's 9 sides. So 9 minus 2 times 180 divided by 9, right? Because I want to know what each interior angle is. So 7 times 180 divided by 9 gives me 140. Okay, so that means each interior angle is 140, but just like we knew before, if you look at the previous example here, each of the lines, each of these, what we call radii or radius, right? Each of these diagonals, that's another way to look at it, each of the diagonals cut our interior angle in half, right? My interior angle was 90 degrees here, but it got cut in half and became 45. My interior angle here was 120, it got cut in half and became 60. So this 140 got cut in half, and now this becomes 70 degrees. Okay, so why is that important? Because then I can do the same thing as I did before. I can cut this nonagon, this 9-sided, into how many triangles? 1, 2, 3, 4, 5, 6, 7, 8, and 9. Cut into 9 triangles. But in order to figure out the area of that triangle, I'm looking at this triangle right here, right? So maybe it's helpful if I draw it out again. In this triangle, I need 2 things. I need the base and I need the height, none of which I have. But I do have something. I know this is 11. I know this is 70, and I know the height must make 90 degrees. So you have to actually cut it into even smaller triangle. So this is why it gets a little tricky, because you're cutting a lot of stuff, right? So I'm going to go ahead and cut this out even more. I'm looking at this right triangle right here. Okay, I'm going to use this right triangle here to help me out, because I know this is 70 degrees and I know this is 11. I need both the opposite and I need the adjacent as well. Yes, we're using our trig to help us now, all right? But you cannot figure out both at the same time. Figure out one at a time. So figure out the opposite first and figure out the adjacent next, right? And this is my hypotenuse actually, right? So I need to solve for my opposite. I have the hypotenuse, so I'm going to use which is sine. I'm going to use sine first. So sine of 70 degrees equals opposite over hypotenuse. So you multiply by 11 on both sides. Remember, we did this a while ago, right? So this is a good reminder. Okay, so 11 times sine of 70 is going to equal my opposite here. So my opposite is about, let's use my calculator here, 11 times sine of 70. That's about 10.337, right? Okay, so that's my height. That's what I want. So this measurement right here is 10.337. Okay, now I need my adjacent, so I'm going to keep going. So for my adjacent, that's adjacent and hypotenuse, so that's which is cosine. So cosine of 70 equals adjacent over hypotenuse, same as before, and we multiply by 11 on both sides. All right, so 11 times cosine of 70 is going to equal to my adjacent, so 11 times cosine of 70, and that gets me the adjacent to be about 3.762. Okay, now This is great, but not complete. 3.762 is just half of my triangle. So you want to double that to get the full base. So my base here, my base is really 7.524. Okay, now I have enough information here. Now I can figure out, okay, one triangle. Area of one triangle is 1/2. Base 7.524 times height 10.337. Okay, so 1/2 times 7.524 times 10.337, and so that will give me 38.888. Okay, and now last but not least, to figure out the entire nonagon, so the final area, just put a big fat A here, nonagon, so it's hard to draw this, so nonagon, I think that's a lot easier. There's 9 of these triangles, so 9 times 38.888 gives me 349, 38.8.992 square units. Okay, zoom out just a bit. Okay, yes, that was a lot of step to figure out this regular polygon. But again, think about it. This is a regular nonagon. It has 9 sides. It's a lot more complicated than just a regular rectangle or a triangle. So of course, there's a little bit more steps. But hopefully these are all steps that you know already, right? We're using things that we've learned in the past lessons to kind of all combine it now. Okay, so same idea here. First thing I want to figure out is how many sides is this, right? So what shape is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, this is a decagon. All right, so I got 10 sides here. Okay, so now that will help me figure out what the interior angle is. So 10 minus 2 times 180 over 10, because that's the interior angle. So that gives me 8 times 180 divided by 10. That gives me 144. Okay, beautiful. So what that does for me is if I were to draw this diagonal down, I know then this angle here is not 144, but 144 divided by 2, 72. So that angle is 72 degrees. Okay, now this time my work is actually half done because it already gave me that height. All I need from the 72 is figure out that base right there, right? So again, reminding yourselves that your goal is to really figure out what the area of this triangle is, but in order to do that, you got to figure out the smaller triangle. You got to figure out this right triangle here, what it is first, all right? So we're going to figure out the little triangle first. This little triangle says we have 72 degrees. I should really draw a bigger picture. A small picture doesn't really help. Okay, this right triangle here is 72 degrees, and this is 5. All right, so we're going to look for this adjacent here. All right, now this is awesome because I actually have enough information to go ahead and solve for the adjacent. I can use tangent of 72 because the opposite is 5 and the adjacent is what I don't know. Remember when your variables on the bottom, you can swap these around. So A equals 5 divided by tangent of 72. All right, 5 divided by tangent of 72 will give me about 1.625. All right. Now, again, remember, that's not the whole base. The whole base, you got to double that. So 1.625, if you double that, then my base is 3.25. All right, so that's the base right here. Okay, so what I can do now, same thing as before, I can figure out my area of the little triangle. So 1/2, so I'm going to figure out this triangle here. So it's 1/2 times base, 3.25, times height of 5, right? This time it told me it's 5. So that tells me then each little triangle is 8.125, right? How do you know how many triangles are there? Hint, it's the same number as the number of sides. So in the nonagon, we had 9 triangles. That's why in that last step, we did 9 times the red triangles. Now this is the decagon. So we're going to do area of decagon. We're going to do 10 triangles. So I get 81.25 square units for this particular decagon. Okay. All right. Moving on. Beth needs to fertilize her flower bed, which is in the shape of a regular pentagon. Okay, it's pentagon right here. Okay, a bag of fertilizer states that it can fertilize up to 150 square feet, but Beth is not sure how many bags of fertilizer she should buy, so she needs to figure out how much her flower bed occupies, right? Beth does know each side of the pentagon is 15 feet long. Find the area of flower bed and tell her how many bags of fertilizer to buy. Okay, so this is great. We have 15. We're going to use the same idea. We're going to have like a center C here. This is the height that we're going to find. And remember that little triangle, the triangle that we're looking for is this, right? And you can see if you finish drawing this, there's 5 of these triangles, okay? Now, we did this before. We know that each interior angle of a pentagon is 108. And if you are like, wait, how do you know that? We can definitely solve that out. We can take 5 minus 2 times 180 divided by 5. So you get 3 times 180 divided by 5. You get 108. What that then tells me is if you divide 108 by 2, you get each angle here to be 54 degrees, right? So that's going to be helpful to figure out what the height is, okay? So then I'm going to do the same thing as before. I'm going to figure out what this little triangle, I'm going to use this little triangle to figure out some information. Okay, I'm going to draw that out. So that little triangle has the information of 54 degrees. This is the height I want. What about the base there? Well, notice how the base, the whole base is 15. I don't want 15. I want half of that, right? Because that little green triangle is only half of the red triangle. So half of that is 7.5. Awesome. And now I can look at this and say, okay, well, I have tangent again because I see opposite and adjacent. So I can use tangent of 54 equals opposite over adjacent. And that h is height, not hypotenuse, okay? All right, so same as we did before, we multiply both sides by 7.5 to solve for the missing height. So I get 7.5 times tangent of 54 equals the height. The height is 7.5, tangent of 54. I get 10.323. Okay, all right, perfect. And now I can figure out the little triangle, right? So area of the triangle is 1/2. Base is 15. My height is 10.323. All right, so, oh, sorry, one more time. So 1/2 times 15 times 10.323. I get the area of each of that, 77.423. Okay. All right, don't forget your last step to figure out the pentagon. There's 5 of these triangles. So area of the pentagon is 5 times 77.423. So 77.423 times 5. That gives me a total area of 387.115 square feet. Right? Okay. So that's the area of this beautiful pentagon. But then how many bags of fertilizer does she need? Because each bag only covers 150 square feet. So now we gotta take my total area, 387.115, and divide by 150. And you will get 2.58. Well, I don't think you can buy half a bag, so you have to round up. So she needs 3 bags of fertilizer. Okay? All right. Let me zoom out. Yes, there's one more down here. Okay. All right. Recently, your school ordered a stained glass window with the design of a school mascot, the rodent. Well, not our school. Our school is the Spartan. Okay. Your student body has decided that the shape of the window to be a regular octagon shown on the right. To fit the space, the window must have a radius of 2 feet. The radius of a regular polygon is the distance from the center to each vertex, and that's this line that we've been drawing in all of our regular polygons. Okay. All right. So we know the radius is 2 feet. Okay. Find the area of the window to determine how much glass the window will need. Okay, so I'm going to use the space down here. I could go ahead and go up and use that space, but I'm going to use the space to kind of draw out what I want to look for. Okay, so first thing is, again, I always start by figuring out the interior angle. So it's an octagon, so 8 minus 2 times 180 divided by 8. So each interior angle is 6 times 180 divided by 8. Each interior angle is 135. And don't forget, you got to take that and divide it by 2. to know that the angle we're really going to use is 67.5. And that's this angle right here, 67.5, right? Okay, and then we are going to also need this height and this space right here, right? So we're going to use SOHCAHTOA again. This is my opposite, this is my adjacent, and the hypotenuse is 2. So I'm going to use sine to find the opposite. I'm going to use cosine to find the adjacent, and that way I have enough information. So sine of 67.5 equals opposite over hypotenuse. All right, and so multiply 2 on both sides. I get 2 times sine of 67.5 to get that the opposite is about 1.848. Okay, and that's my height. And then I'm going to use cosine to figure out my bottom line there. So cosine of 67.5 equals adjacent over hypotenuse. So same step, I'm going to multiply by 2 on both sides. So my adjacent is going to be 2 times cosine of 67.5, and that would be about 0.765. Now remember, that's not my full base, so I always have to double that adjacent piece. So 0.765, if I double that, that will give me the base to be 1.53. Okay, so the height is 1.848, and the base is 1.53. So then for my triangle, right, this is always the triangle I'm looking at. So I'm looking for this triangle right here, this triangle. Okay, so I can figure that out first. So area of that triangle, I'm going to use the space up here now. So area of that triangle is 1/2. My base was 1.53. My height was 1.848. So 1/2 times 1.53 times 1.848. And that gives me the area is about 1.414. And now this is an octagon, so we know there's 8 of these triangles. So the area of the octagon is 8 times 1.414. So 1.414 times 8. I have a total area of 11.312. And let's see, it's feet, so this is square feet. So that's how much glass the window will cover. Okay. The edge will have a polished brass trim. Each foot of trim will cost $48.99. How much will the trim cost? Okay, so right now we're only looking at the outside, right? We're looking for the perimeter of this thing. So we're looking for, let me see if I can get the color to be a little better. We're looking for this, right? And we got the base to be 1.53. There's 8 sides, so we can go ahead and utilize that and go 8 times 1.53, that's your perimeter. So 1.53 times 8 to get 12.24 feet, and each foot costs $48.99. So we're going to take 12.24 feet times $48.99, because that's how many feet we need, right? So $48.99, it's going to cost us $599.64. Well, that's very, very expensive, but that is the cost of the window trim. Okay, all right. So again, make sure you spend some time reading the methods and meanings. It's talking about interior, exterior, angle, or polygon, just reaffirming the same formulas that we've been doing in the last couple lessons. Okay, that's it, guys.